Alright guys, I'm hoping you guys tried this on your own. You have 3 blanks to fill in there. And I wanted you to just pause this thing and try it on your own before you get in the next video. So a product is negative if it has a blank number of negative factors. I'm talking about a number of negative factors. And you could say 1 or 2 or 3 or 4 or 5 or 6. But I want to have sort of a universal word here. So if you have 3 or 5 or 7 or 9 negatives here, like a negative times a negative times a negative times a negative times a negative, you'll always get a negative. Hopefully you're realizing that that word is an odd number of terms. In other words, there could be 1 negative sign, or 3 negative signs, or 5 negative terms being multiplied. That result is because every pair cancels. So these 2 negatives cancel, that one is still there. These 2 pairs cancel, and those 2 pairs cancel. So, you know, the exact opposite of this would be a result is always going to be positive if there's an even number of positive factors, or sorry, of negative factors. So you multiply 4 of these, or 6 of these, or 8 of these, or 10 negative signs, you're going to get a positive result. So dive into these next 3. This is definitely on the back of your page. I think I might have messed that up before, but this is definitely on the back of the page. These are evaluating expressions. We haven't done much of this. So you have these things in terms of x. I'm going to give you a value for x. So x is equal to negative 5. I don't know if I put that on your paper already. Sometimes I don't. I'm tricky. I might have been stingy here. But I want you to take this value of at negative 5 and plug it in for any x value. So it's basically just substituting it in here. So negative 5 is going to be used for x here. Negative 5 will be used for x here. And the same thing over here. And then we get into these implied operations. When you see 4x or negative 4x, multiplication is implied. This is not negative 4 minus 5. This is negative 4 times 5 times negative 5. And you guys know a negative times a negative gets you a positive. The second one here, be careful with how you do that. That's negative 2 times negative 5 squared. We're not talking a lot about PEMDAS yet, but we're going to start to do parentheses, exponent first, before we multiply the 2 times 5. A lot of people incorrectly get 100 for this answer. This answer is not 100. You would do the exponent first, or another way to think of this is just write out all the factors. Squaring something is really multiplying it by itself, so it's negative 5 times negative 5. If you do the problem this way, you'll see it's definitely not 100. It's not even negative 100. 2 times 5 is 10, and this should be positive. 10 times negative 5 gives you negative 50, so not even close to 100, not even close to negative 100. The last one should be kind of a simple one. You plug in the negative 5, and you get negative 35 when you multiply. So there's some implied multiplication. This is called variable substitution, where you replace the variable. I've got one more like that. And here's the given value for x. It's not the same as the previous problem. X is now negative 3. So you plug that in. First one, you should obviously get a positive number. You should get positive 6. Be careful on the second one. It says number 5 over here. When you plug a negative in here, and you already have a negative sign, this is that double negative. So this is going to become positive 3. This is going to become positive 3 because there's like too many negative signs on there. This kind of connects what you guys did on Tuesday with what you're doing today. Leave the negative 5 alone for a minute. These cancel, becomes positive 3. This is like minus a negative. Or you can think of it as a negative times a negative. You know, there's 5 negative signs in there. There's an odd number of negative signs. You should get a negative answer on here. You should end up with negative, and that's, of course that's not right. Negative 45 is what you should end up with. Scratch that. Negative 45, because it's 5 times 9. Again, those copy and paste getting me. Okay, lazy teachers today. These last two are a little tricky, and like I said, I'm trying to preview some exponent stuff. It does matter whether there's parentheses on the outside or the inside sometimes. So the exponent's out here and the exponent's inside here. Sometimes that matters. Here's how I would approach that. Plug in negative 3 here. This negative sign is the one that was already here. Is that one. This is the negative 3 that's attached to the original number. So now you've got to look at this and go, well, what do I do now? Think of this as a 4 here. Think of this as an invisible negative 1 sitting right here. So it's 4 times negative 1 times negative 3 times negative 3, because there's 2 of these negative 3's. A lot of times I'll expand it like that. And I might even put a negative 1 on my paper here so I really understand this. There's actually 3 negative factors in here, which means this answer should end up being negative. 3 times 3 is 9. 9 times 4 is 36. And like I said, it should be, boy, a lot of mistakes from this teacher today. It should be negative 36. Good thing you can't see it, actually. It's off your screen. So this result should be a negative number here. So this is what happens when you try to rush through things, people. 7's kind of the same thing. It's very similar. I've got the negative I plugged in here, and I've got the negative sign that already existed. So within the parentheses, I can simplify within the parentheses. Like I said, I'm previewing some PEMDAS in here. I would probably do the negative times a negative and cancel that. And now it's just 3 squared, 9. And then 9 times negative 3 should get negative 27 on this answer. That one I got right. So ignore this wrong answer over here. Should be negative 27. And over here should have been negative 36. So I got wrong. 50%, not very good, coach. Not very good math coach. Last one's on your paper. Give these a try. You'll see we got some fractions at the end. You guys love those. And I love my directions here. They say to simplify with no other instruction. And students will very often ask me, well, what do you really want me to do? Simplify is its own expression. Do whatever the symbols tell you to do. For example, parentheses here in between the numbers are implying you know you have to multiply. As opposed to this. This does not say 5 times negative 8. This says 5 minus 8. That's a subtraction problem. Multiplication problem. Subtraction problem. Multiplication. It's a subtraction problem, but if you remember from a couple days ago, when you see minus and negative, you're actually going to change this to plus, so it's an addition problem. This is sort of an addition problem because they're both negatives. But it's not multiplication, it's not multiplication. We got some review on here. Subtraction or addition problem. Subtraction, addition. Subtraction, addition. Subtraction, addition. We only have a few multiplication problems in here, so I want to make sure you don't lose track of what we did a day ago. You'll see the homework assignment is kind of the same way. Good time to pause. Try these on your own. I'm going to rattle some answers up here in a minute. I strongly encourage you not to just look up here for the answers for these especially. Give them a try. Pause it. Come back to check out. See if I got them right. Negative 3. Good, I got one right. Negative 36. Good, I got one right. Good job, Mr. Hess. You got 3 right. 4 right. Negative 24. I'm on a roll. Positive 11. I got them all right so far. Not bad. Negative 10. I've got that one right. Hopefully you're okay with that. Good time if you want to compare answers with somebody. Again, you don't have to just look at mine on here. Positive 7. I'm actually correct on that. This becomes positive 8. 8 minus 1 is 7. Negative 13 on the next one. Positive 13 on the next one. This just becomes a plus sign again. It's like a double negative. Got to get common denominators when you're subtracting or adding fractions. So just kind of reviewing that, making sure you don't lose track of that. Common denominator between 2 and 5 is 10. So 1/2 is the same as 5/10. Probably want to change that to 5/10. 2/5 means you multiply the top and the bottom by 2, and you get 4/10. I attach this negative sign here. I don't care how you do that. You can just do 5 minus 4. You just subtract the numbers. You have 5/10 of something, and you're subtracting 4/10 of something. This is like 50 cents minus 40 cents. You get 10 cents or 1/10 of a dollar. Did I say that right? 10 cents or 1/10 of a dollar. So hopefully that one makes sense. Nothing to reduce or simplify after that. Easiest thing to do with fractions is to multiply them. So we did this a couple days ago, but we didn't do it with negative signs. Negative times a negative, hopefully you're positive about your answer. Negative 2/3 times negative 4/5, just multiply straight across. You get 8 on the top, and you get 15 as a denominator. Easy as can be. There it is if you want to check it. Sorry about that, folks. The homework, guys, you should have plenty of time to tackle the homework, is a mix of problems here. See page 63, 11 through 24. I will collect this on Thursday when I'm back for the beautiful beautiful Thursday morning. Sorry, guys, I wasn't here. Hopefully this keeps you guys, learning a little something. Gives you a chance to rewind if you missed something. But it's really just some review of concepts. Should be an easy day for you guys. Have a good one. We'll see you tomorrow.